Hi everybody. In this video, we are going to be talking about estimation with decimals, which is unit 3.2.3. And one thing I want to point out first is that estimation with decimals is similar, but also different from what we were just talking about with rounding decimals. Excuse me. Ugh. So in this topic, we talk about ordering and rounding decimals. And rounding decimals means, if you guys remember, that we are rounding to a specific place value. So we might all say, let's all round our answers to the tenths place. And so that would mean that at the end of our problem, all of us should end up having the same answer. Well, that's not necessarily true with estimation. With estimation, we might all end up with different answers, but those answers should be similar at the end. Like they should be close to each other in numeric value. But they may not be the same exact answer, just depending on how we chose to estimate. So again, it's going to be dependent on the scenario based on how you'd like to estimate. So sometimes we need to estimate and we need to estimate more accurately. And sometimes we just need to estimate just to get a decent figure in our heads. Like if we're going to go to the grocery store and we've got a $20 bill in our pocket, we might estimate a little bit high on all of the items that we're picking up off the shelf so that we make sure that we certainly have enough money once we get to the checkout counter with our items and our $20 bill. So anyway, as we work through today's problems, what I really want you focusing on is thinking about what is the scenario? Is it better to estimate a little bit high? Is it better to do a more accurate estimation? What's going to be the best form of estimation for each problem? So with that, let's get started. And I've got to get my pen tool going. And I don't know where it went. There it is. I don't know what happened to my pen tool there for a moment. Okay, sorry about that, guys. Here we go. So estimation with decimals, being able to estimate is our first blank. Being able to estimate your answer is a very useful skill. Not only will it help you decide if your answer is reasonable, which is very true, when doing homework problems or answering test questions, but it can prove to be very helpful in everyday life as well. So when shopping, you can estimate how much money you have that you've spent, or you can estimate the tip for a restaurant bill or the price of an item on sale. By rounding and then doing a quick calculation, you will at least know if you are close to the exact answer. So the exact answer is an answer where we haven't rounded, we haven't estimated, and so that would be considered your exact answer. Additionally, there is not an exact science for choosing which place value to use to estimate. However, you will need to assess the situation. This is kind of what I was talking about a few minutes ago. You need to assess the situation and decide which place value makes the most sense to estimate. Okay, so let's look at our first scenario. So it says Charlie wrote checks for $64.20, $47.89, and $95.80. Estimate the total of all three checks. And again, if we were sitting in class together, what I would have you do is first think about your own estimation method in your head. And then I would have you share it with the person sitting next to you. And then we would talk about it out loud. So what I would like for you guys to do for this entire page, so page 30 and 31, what you guys can do is go ahead and just pause this video and then go ahead and think about each of the scenarios and how you would estimate, and then maybe write down your ideas just quickly in the margins, and just so it kind of jogs your memory when we get to those problems about what your idea was. And then you can compare it to some of the methods that I use. And again, just because you did something different doesn't mean it was wrong. It does mean that you need to look at it and say, did I get a close enough answer to Liz's at the end of this, that it would be okay? And if you're not sure, then ask me in class or text me your, take a picture of what you wrote down and send it to me and say, would this type of estimation method work for this problem, or are you wanting something a little bit different? And honestly, when I'm wanting something different, it's because we really have to be careful about our estimation methods. So for example, like this first one, we're talking about a checking account. So I absolutely want to make sure that your estimate is either really like it's super close to the exact answer, or that it's going to be a little bit above the exact answer, because we absolutely do not want to bounce a check. Because if you bounce a check, if you've ever done it before, not only now do you have $0 in your bank account, but then they charge you a fee on top of it. So not only do you have no dollars, now you have negative dollars sitting in your account, which is certainly not good. So I'm actually gonna give you a couple different methods that you could maybe choose for this one. One of them, I think about like easy mental math. So here's one where it's like, I'm gonna estimate high, and then I'm also gonna do easy math. So determine the best way to estimate for this problem. So here's one method. Estimate high. Because I don't want to bounce a check. And choose easier numbers for mental math. So the other thing I haven't talked with you guys about yet is this word justify. Justify, think about that. It's like a court of law, like justify why you just did what you did. So that's like, or like talking with your parents if you're getting in trouble. You're like, well, I did X, Y, and Z because, and then you giving the reason why you just did those things is your justification for what you did. So I don't want to have just the what. Like this is so, I get this so frequently. People will just like, students on these types of problems will just explain to me what they did. Well, that's half of the points for that problem, is explaining what you did, but then you tell me why. Like, why did I do that? And so that word because should be in there, because that is telling me why you chose the method that you chose. So make sure that that word because is in there, and then you're explaining why you did what you did. Okay, so here's my one method of estimate high, but easier mental math numbers. So if I go 6420 and 4789 and 9580, and if I'm just going like quick, easy mental math, I might say, okay, this I'm going to round up to 65. This I'm going to round up to 50. And maybe this I'm going to round up to 100. And again, I know that that's going to be way over. I mean, it's going to be like maybe about somewhere between $6 to $10 more than what my actual answer is. But again, we went for high and we went for easy math. So here we are saying that is $5, and then this gives us 11, and then that's 215. So here's one method. Our next method is maybe a little bit more balanced, a little bit more accurate. So balanced and more accurate estimation. Because I need a more accurate amount for my checking account. So either one of these, if you had written down either one, the one that was in black, the one that was in orange, either one would be okay. All right, so here we go. This is a more balanced, more accurate method. So it's not going to be as easy in our mental math heads, but that's okay. So here we had 64.20, then I have 47.89, and then I've got 95.80. All right, so maybe on this one, I think I'm still going to go up to 65. And so I'm kind of keeping track of this. So that means that I estimated high 80 cents. So right now it's like as if I've spent 80 cents more than I actually did. So I went up 80 cents. Then here I'm going to say, well, maybe I want to still do 50 because that's still going to be easier. So maybe I'm going to do 50. And so here again, so if you think about, okay, well, 48, 49, 50, that's $2.11 that I estimated high. And then here, that means like if I look at the 95, it's totally okay to go down on this one because I've already gone up for these other two. So here, if I say, I'm going to actually say 95 for this one. And this time that means I actually went down by 80 cents. But guess what? Here I went up by 80 cents. Here I went down by 80 cents. Those kind of cancel out, which means so far my estimate at the end will still be $2.11 more than my actual amount. So now let's add it. 5 and 5 is 10. And then I'm going to do 9 and 1 is 10 plus 11 is going to give me 21. And so this one gives me 210. So that means the actual, if I even wanted to come back here and say, well, the actual amount is actually $2 less. So that's 208 and then minus 11 cents. So that's 207 and 89 cents. So here's your actual, what it actually is. And so both of those are pretty close. Like if we're doing quick mental math versus, a more balanced method that we probably would need like a little, maybe like a paper and pencil, then that's okay. Again, you just have to explain why you chose the method that you chose. So anyway, that looks pretty good. So it says, now let's all round to the ones place and find a common answer. How do your answers compare? So here, this is specifically only rounding, not really, yes, we're estimating, but we're estimating to a specific decimal point. So here, if we round to the ones place, we've got $64 because that 2 is going to tell the 4 to stay where it's at. So $64. The next one would be $48. So this one, again, we went down by 20 cents. Here, if we went up to 48, that is going up by 11 cents. And then this one would be going to $96. And so that again is going up by 20 cents. So these down by 20, up by 20 kind of cancel each other out. So this one's only going to be off by 11 cents. So here I've got 6 and 4, which is 10, plus an 8, which is 18. And then I'm going to group these again. 9 and 1 is 10, 6 and 4 is another 10. So that's 20. And so this is super accurate. So that's the most accurate. But again, comparing to what we've had, these are all very similar. So any one of these would be totally fine for your estimation methods, because look at how close they all are to the actual. So that's fine. Again, I'm hoping that you have paused this video. You've already had an opportunity to work through this problem, because I love the way that you guys come up with this. You guys come up with lots of different ways to do this than I do. And it doesn't mean it's wrong. It just means it's different than what I did, and that's okay. All right, so here Sherry has $55 and wants to buy CDs that cost $11.49 each. About how many CDs can she buy? Determine the best way to estimate for this problem and justify your answer. Well, again, we don't want to get up to the cash register with too many. And so I've seen students do a couple different things where they say, okay, well, this is close to $12. And so maybe they round that up to $12. And then they just start doing multiples of it. So knowing that, it's going to be 12, here, I'll just write it out, 12, 24, 36, 48, and then 60. So if we're doing multiples, this would be 1 CD, 2 CDs, 3 CDs, 4 CDs, 5 CDs. And so you can see if we have 55 bucks, it's going to end up being 4 CDs here. So one method is to round CD to $12 and find the multiple that is closest to 55 without going over. And then you would explain why. So again, that tells me the what. Here's what I did. Now tell me why you did that. We rounded 1149 up for easier calculations and also to not go over budget. And this tells you the why. So again, here's the what, this first part from here to here, and this tells you the why. This gives you the justification right there. So just make sure all of your answers have those pieces on it. So now estimate based on your idea above. And so what we found out is that 12 times 4 gives me $48, which means we can get 4 CDs. Now it says, let's all round together, round 1149 up to the nearest dollar so you don't underestimate the cost. So that one means, again, we're taking 1149 up to 12. Now divide 55 by the rounded cost. And so if we take 55 and we divide it by 12, we're going to get 4.583 repeating. And so again, what that means, we can't buy a partial CD. So that means 4 CDs is going to be our answer. And again, by the way, if you happen to use the same method as above, you can just state that. You can just say, I use the same method as above. You don't have to rewrite it. Mine, this method here in C was a little bit different than mine because I did multiples of 12 rather than just straight dividing. And how do our answers compare? Excuse me, our answer at the end of 4 CDs is exactly the same. The final answers are the same. All right, so let's look at number 3. After a delicious meal at a restaurant, the bill for 2 is $45.36, which includes tax of $3.74. The service was very good. If you estimated, how much tip would you leave if you follow the rule to double the amount of tax? Use estimation to find your answer. All right, so if we've got $3.74 and you're wanting to use the method of double. So maybe one method is we round that to $3.75. That's one method I've seen. Another method I've seen students try is that they actually like to round it up to 4. That's pretty darn easy to do that mental math. If it was me, I'd go this way because that's so easy to figure that out. That's $8. And so my tip would be $8. If you're doing this way, you might want to do something like split it up where it's 3 times 2 plus 75 cents times 2. And so this gives you 6. And then think about having 2 sets of 3/4. So 75 cents plus another 75 cents is going to give you $1.50. And so then your answer on this one would be $7.50. And for me personally, I'm like, you know what? Even if I'm a poor college student, I like to live my life generously. And so why not give the extra 50 cents? Give them $8. Um, I always love this conversation in class when I get to have this conversation with you guys in class, is that I've heard so many students say, "What? I'm not going to give a tip. I don't give a tip for anything because I'm a poor college student." Well, then you shouldn't be eating out at that restaurant, to be honest, because guess what? The servers there and like the hostesses, their hourly wage is based like they actually get a lower than minimum wage for their hourly wage because their employers are expecting them to get tips, which would supplement their hourly wage to get them up to even minimum wage. So, absolutely tip your servers because otherwise they are making less than minimum wage. And if you don't have money for a tip, then save up until you do before you go to that restaurant. All right, so here we go. Another scenario with the same type thing. If you estimated how much tip would you leave if you follow the rule, excuse me, of giving 20% of your bill, use estimation to find your answer. All right, well, let me write up my bill. My bill, including the tax, is $45.36. So here's what I like to do. I know we haven't talked about percentages yet, but you guys have worked with percentages before, um, and like sometime in your life. So even if we talk about taking 10% of our bill, well, first of all, let me round this first of all. So if we've got 45.36, maybe I round that to $45. And then I take 10% of that. Well, 10%, take your decimal and move it one place to the left. And that is finding 10%. And when we move it one place to the left, our 10% is $4.50. And then 20%, if I just do another 10% here, right? If I know that 10% is 450, that means another 10% is 450, which means 20% is going to be those two added together, which is going to end up giving you $9 because this is going to be 0. That's going to be a 10, 4, 8, $9. And so that's typically how I end up tipping, as I will take and give 20% of my bill. And if you look, 20% is actually going to be a tiny bit more than $9. So honestly, for me, I might just throw down a $10 bill, or I might give like $9.50 or something. But again, it's like, why am I worried about 50 cents? Just if I already have a 10 in my wallet, I'm gonna throw down a 10. Okay, let's look at the next one. Evelyn is purchasing 287 ceramic tiles for her new kitchen. Each one costs 21 cents. Which of the following is the most accurate estimate for the cost of purchasing the tiles for her kitchen? Figure out the method she used to estimate. Okay, so the first question is, which one is the most accurate? So again, I'm hoping that you've already worked through this problem. If you haven't, pause this video. I want you to pause it and try it on your own. And then come back and watch this video. But we here are essentially figuring out the answers to two questions. We are figuring out which one of these is the most accurate. And then once we figure that out, we've got to figure out the method that she used. So if I'm trying to figure out which one is the most accurate, I'm actually going to figure out, well, what is the exact amount? So if I'm getting ceramic tiles and each of them cost 21 cents, my most accurate is just figuring that out. I'm going to take the quantity of the tiles and multiply it by the price. So I'm going to take 287 times 0.21, and that gives me $60.27. So I did 287 times 0.21, and that gave me $60.27. So which one of these is the most accurate to this number? It would be B. That's the closest. So then we've got to figure out, well, what was her estimation method? So to me, when I think about 60 and I'm thinking about, well, what are some multiples of 60? I've got, like 1 and 6. So that could be 60. I've got 2 and 3. So maybe that's, like 20 and 3, or is that 203? What's it going to be? So I'm thinking about the facts that these are my multiples and trying to figure out how in the world am I going to manipulate this number and this in order to get 60? And what I look at is that 287 looks like it could round up to 300. And then that 0.21 looks like it could round down to 0.20 to 20 cents. And that is exactly 60 bucks. So here's her method. She rounded the 287 up to 300 and she rounded this down to 20 cents to give us $60. Now, if you look at this, this estimate was a little bit low compared to the actual, but again, we're thinking about the scenario. If we're just like, about how much did I spend on those tiles? And it would be close to 60 bucks. And I would agree, that is close to 60 bucks. Oh, excuse me. Okay, so let's look at the next one. Administrators as a school have set aside $25,000 to cover the school's new soccer field with the sod. The field is 102 meters long and 64.5 meters wide. If the sod costs $4.04 per square meter and it comes with free installation, estimate the cost of this project. Then determine whether the school can do the project with the amount of money they have set aside. All right, so here's what I think. I think that what we could do is actually figure out what the actual cost is going to be. And then we can do our estimation method because we want to make sure that our estimation method at the end is going to be accurate. So I always like to, again, because this is for class and we're learning about estimation methods, I would absolutely figure out, well, what is it supposed to be so that I know at the end if my estimation method was okay or not. So again, when we're figuring out this, we are supposed to figure out our area of our rectangle. And don't forget, area is going to be length times width. And then we are saying that every square meter is $4.04. So then we're going to multiply it by $4.04 and see what the actual cost is. So here we go. So again, our cost is going to be our area times the $4.04. And so first we've got to figure out our area, which is 102 times 64.8. So 102 times 64.8 is going to be 660.9. Oh, I misread my decimal. Let me get rid of that. It's going to be 6,609.6 meters squared. And then I'm going to multiply that. I'm going to put that in right here. 6609.6 times 4.04. And then that gives me the cost of $26,702.784. So what that tells me right now is, guess what? We have almost enough money, but not quite. So we should tell the school to hold off. We should not do this yet. But let's figure out a decent way to estimate for this. So here, let's be careful, because when I look at this, I think, I think maybe we could do 100 times 65 and then multiply it by 4. And let's see if that would get us there. But I don't know. We're going to find out if that estimate's kind of low. So here's our estimate. And I don't know if you're like, what I'm thinking about is that 102, I'm actually taking off 2 meters here. It's as if I just cut those off. And so I'm saying, oh, my estimate is going to be 100 instead, but then I'm going out a little bit more to 65. And so I'm totally changing my dimensions. And we're going to see if this estimate method is okay or not. So let's say we do our 100 times, this is our area, 100 times 65, which is going to give us our 6,500. And then we are going to multiply that by 4. And if we multiply that by 4, So you can put it in your calculator if you want to. You could possibly do this one in your head too. We end up with 26,000. And then we look at that and say, well, did that come out good enough or not? Well, look at our actual. That's pretty good. But the main thing is I want to check out is, was it over the 25,000 so that we can give good advice? And it was. It was over the 25,000, in which case we tell our administration, hold off. We're not ready to start this project yet. We still have to earn some more money. This is one of those scenarios that I would say doing a more accurate estimation would be so very important, to the point that I would say this is probably not the best scenario to do estimation on, because it's so important for us to advise our administration appropriately in this, to say, you know what, let's find out what the actual answer is so that we make sure we don't start the project and then all of a sudden we can't finish it. And then maybe we don't finish the sprinkler system that needs to be on that sod in order to keep it nice and green. And then we totally lose our investment. That would be a huge bummer. Okay, that's it for this topic, you guys. Thanks for tuning in.